Okay, I thought I would try some of these in section C just because I know that they can tend to be confusing. All right, one of the things we've been doing to get our problems factors is we've been saying, I'm going to multiply to get the number, the coefficient of the last term. A lot of times it's just a number, but here, instead of just a number, I have y to the fourth. I'm still going to focus on that number, okay? I'm trying to multiply to get negative 16, and I'm still trying to add to get the coefficient in the middle. This is how I'm going to approach this, but I'm going to show you what else I'm going to do. A lot of times when we factor, we do this, and we put an x here and an x here, and that gives us our first term, which is x squared. Here I don't have an x squared, but I do have x to the fourth. So let's think about it. What if I put an x squared here and an x squared here? If I multiplied those two first terms, I would get that x to the fourth, wouldn't I? I can treat problems that have x to the fourths in them and x squareds in them just like I do these other ones. I just have to tweak them a little bit. Another way I'm going to tweak it is usually on the end term down here. I usually just have this like I normally would have just had minus 16 in a lot of the problems in our lesson today, but then I get this y to the fourth. Well, if you think about it, this last term always comes from multiplying this number and this number when we go to check our answer. So I'm still going to find the numbers I'm going to put in that spot, but because I got this y to the fourth right here with that number, what I'm going to do to get it back when I multiply is put a y squared in those terms. Now, I'm going to figure the numbers that go in here and I'm going to stick them in just like I normally did. All I had to do was tweak this, and we'll check it to make sure you see that it really does equal what we what we want, what we started with. All right, so let's see. What multiplies to give me negative 16 and adds to give me negative 15? Okay, so if you're multiplying to get a negative, we got a negative and a positive. So it would be, might be 1 times negative 16 or negative 1 times positive 16. I could keep going, but if you look, I've already got what I need here. I could list the 2 and the 8 and the 4 and the 4 that multiply to get 16. But notice, 1 plus negative 16 is negative 15. So I want a 1 here and I want a negative 16 here. So this is a positive 1. So what I'm going to do is in my first term, I'll put a plus 1y squared, which again, I don't really need that 1 if I got that y squared there. So what I'll end up doing with that term is just writing it as x squared plus y squared. And then on my second term here, I have this minus 16, so I'm going to put minus 16 y squared. So it will be x squared minus 16y squared. Okay, this is how it factors. And as a matter of fact, this one kind of keeps going. So I'm going to have to keep factoring that one. Now let me just show you that what I have so far really is equal to what I started with. And then in a minute I'll come back and I'll keep factoring that because this right here is the difference of two squares, so it will factor some more. But let's just check to see that what we have really is what we started with so far. X squared times x squared is x to the fourth. X squared times minus 16y squared is minus 16x squared y squared. Okay, now let's distribute y squared. Y squared times x squared is plus x squared y squared. It's a like term with that term right before it. I'm going to put a 1 in front of it because there is one of them in there. And then y squared minus 16y squared would be minus 16y to the fourth. If we combine these two middle terms, I have minus 15x squared y squared. I'm just copying down the other terms. Isn't that what I started out with, that right there? It is. Okay, now I'm not finished factoring though, because go back to this step. Remember I said that this second parentheses here could be factored a little bit further. So I'm going to copy down my first one. It will not factor because it is a sum of two squares, not a difference of two squares. But this x squared minus 16y squared, I can rewrite these two terms here as x squared minus 4y squared. So it's a difference of two squares, isn't it? So what I'm going to do is keep factoring it. I'm going to say this is x minus 4y and x plus 4y. That would be completely factored when I got it down like this. Okay, So again, the only reason I stopped with this orange in the middle was just to prove to you that what I did here actually did work on 47. I'll go ahead and do 49 and 51 because if you're having trouble with 47, I'm sure you're struggling with this other one too. Y plus 3 squared plus 5 times y plus 3 minus 24. Okay. Now, a lot of times in math, there's a little thing we can do, and you don't have to do this, but sometimes it helps people. What we're going to do is just for a minute, let's make a simple substitution. I'm going to call y plus 3, I'm going to give it the letter a. I'm going to say it's equal to a. And then I'm going to rewrite this as a squared plus 5a minus 24. Could you factor that? It looks a little simpler, doesn't it? Sometimes if something looks too hard, do this. This is called substitution, making a quick little switch out for something that looks a little simpler, and then at the end we'll switch it back in. You could probably factor this with no trouble because you're going to say, okay, if it factors, it's got to multiply to give me negative 24, the constant term on the end, and it has to add to give me the number in the middle, the positive 5. And is there anything that works here? Let's see the different ways we could get negative 24 would be negative 1 in 24 and 1 in negative 24, but that doesn't nowhere close to 5 if I add those together. 12 times 2, 2 and 12, whether it's negative 2 times 12 or 2 times negative 12, nowhere close to 5. We either get 10 or negative 10, right? So let's look at 3 and 8. 3 and 8 have a difference of 5. Negative 3 and 8 or 3 and negative 8 would both multiply to get me negative 24. Which one would add to give me positive 5? It'd be this one. Negative 3 plus 8 would be positive 5. So I need to put negative 3 and 8 in here. And so this actually factors into A. Let me put my A here and my A here. And my minus, let me go ahead and do that in green since I wrote them in green. My minus 3 and my plus 8. Now, that's not quite the problem, though, is it? The thing about it is up here I said A was really equal to y plus 3. So what I'm going to do now is go, oh, well, A was really y plus 3. Okay? So everywhere I see the A, I'm going to put the y plus 3 back in. I just switched it out for a minute so my brain could handle it, okay? And then I still have the minus 3 and the plus 8. I can see, though, that once I do that switch back in, that I can keep simplifying this because y plus 3 minus 3 is just y, and y plus 3 plus 8 is just y plus 11. So this really factors out this way. Another way you could have done this, which would have been a lot more work, would have been to multiply out y plus 3 squared and multiply out 5y plus 3 and simplify all those terms. And you might have seen how to factor it that way. But this little thing called substitution here is an important idea in math, and we use it a lot. We use it a lot in calculus. It's a big idea in calculus. So it's kind of good that you get used to it now and practice using it instead of doing this the long way and multiplying all that out and then factoring it. Let's go ahead and try 51 because I know that one also was not on a video. We're going to do the same thing on 51 as we did on 49. We have a plus b squared. And we have minus a plus b and a minus 2. Okay, too much for our brain sometimes to think about. So let me just make a substitution. I can pick any letter I want to. I'm just going to pick M. I'm going to let M, just going to call a plus b M. Okay, so then I'm going to rewrite this just temporarily. That's going to be M squared minus, oh, there's another a plus b, so that'll be M minus 2. Okay, so let's come over and do our little factor tree. Again, you don't have to do this little graphic organizer. I'm just showing you what we're thinking. We're trying to say I'm trying to multiply to get the constant on the end, the minus 2, and at the same time I'm trying to add to get the coefficient in the middle, which is a minus 1, even though the M does not have that 1 written in front of it. It's really there, isn't it? An M is the same thing as a 1M, okay? And a negative M is the same thing as a negative 1M. Okay, well, can this work? Can I find two numbers that multiply to get 2 and add to get -1? The only way to get 2 is 2 times 1. And to get a -2, one of the numbers needs to be positive, one of the numbers needs to be negative. Well, if I want to add them up and get a -1, it would be a -2 times a +1 would give me a -2, and -2 plus a 1 would give me a -1. So this actually factors, and I'm going to go factor it, and since I simplified, the way this looks, it's just going to have an m here and here. It's going to have a -2 on one of them, and a +1, so I'll put a +1 on the other one of them. Okay, now, did I have m's in my original problem? No, I did not. So it's time to switch back. Everywhere I see this m, it's equal to a plus b. So I'll go, oh, instead of m, I'll write a plus b minus 2. And over here, instead of this m, I'll write a plus b. Oh, and then there's the +1. And it's factored. And this one I get to stop because there's no way to simplify those factors. So what I have up there at the top can be factored like this.